80 miles off the coast of England, sitting 700 meters beneath the floor of the North Sea, there is a hole in the earth almost 2 miles wide. For 20 years, scientists stared at it and argued about what it even was. Some said it was just shifting salt underground. Some said it was an ancient volcano. Nobody wanted to say the real answer out loud, because the real answer was almost too strange to believe. An asteroid the size of a football stadium hit that spot at over 40,000 miles an hour. It happened so long ago that the North Sea itself didn't exist yet in its current form, and when it hit, it didn't just leave a crater. It threw up a wall of rock and water 1.5 kilometers high, then sent a tsunami taller than Big Ben racing across the ancient ocean. Nobody knew this happened for over 40 million years, and by the end of this video, you'll never look at the ocean floor the same way again. Most people think we already have a complete map of every asteroid impact on Earth. You've probably seen the famous ones: Chicxulub in Mexico, the crater that wiped out the dinosaurs; Meteor Crater in Arizona, the one everyone's seen in documentaries. It feels like, at this point, scientists have found the big impact sites and cataloged them. Here's the crack in that idea. 70% of our planet is covered by water, and an asteroid doesn't need to hit land to change history. It just needs to hit anything. When something slams into the ocean floor, the crater doesn't stay clean and visible like it does in a desert. It gets buried. Sediment piles on top of it for millions of years. Rock shifts. The evidence gets erased from view, even though it's still down there, waiting. That's exactly what happened in the North Sea. A crater sat there, fully intact, for over 40 million years, and modern civilization didn't notice it until an oil company happened to be scanning the seabed for something completely unrelated. So here's what we're going to answer today. How do you find a crime scene that's been buried for 40 million years? What actually happens in the seconds after an asteroid slams into an ocean? And why does this discovery matter for you right now in 2026? Let's go deeper than anyone has ever taken you before. In 2002, geologists working for the oil and gas industry were using seismic surveys, basically sound waves bounced off the seabed, to map the rock layers underground, to search for drilling sites in the southern North Sea. Animator, sonar, waves, pulsing, down, through ocean layers, revealing circular structure on a screen. What they found instead was strange. Buried 700 meters below the seafloor was a nearly perfect circle, almost 3 kilometers wide, with a raised bump right in the center like a bullseye. They named it the Silverpit Crater. The shape was the first clue. Impact craters have a very specific fingerprint: a rim, a bowl, and often a central peak formed when the ground rebounds upward in the instant after a strike, almost like a drop of water splashing back up after a stone hits a pond. But that same shape can also form from shifting underground salt or ancient volcanic collapse. So for 2 decades, nobody could prove which one it was. It became one of the most famous open arguments in British geology. Here's where the real detective work started. A team led by researchers from Heriot-Watt University in Edinburgh went back with better tools, high-resolution seismic imaging, and old rock samples pulled from a nearby oil well decades earlier. Animator, character, examining, tiny rock, fragments under a microscope, crystal, structures. Inside those samples, they found something salt-shifting, or volcanoes simply cannot produce: quartz and feldspar crystals with a shocked internal structure, a fractured, deformed pattern that only forms under the kind of extreme, instantaneous pressure you get from a hypersonic impact. That was the smoking gun. But here's the part that nobody talks about. Finding that evidence wasn't luck. It was a needle in a haystack search through fragments smaller than a grain of sand, from a rock sample drilled up decades before anyone even knew to look for it. Once the impact was confirmed, scientists ran the numbers. The object that made this crater was roughly 160 meters wide, bigger than a football stadium. It struck the seabed at a low, grazing angle, coming in from the west. In the first few minutes, the impact blasted a curtain of vaporized rock and water, 1.5 kilometers into the sky. When that curtain collapsed back down, it triggered a tsunami over 100 meters high, taller than Big Ben, racing outward across the ancient sea. Did you know the impact has now been dated with incredible precision? By studying fossilized plankton preserved in the sediment layers right next to the crater, researchers pinned the event to the Middle Eocene epoch, somewhere between 43 and 46 million years ago. That's roughly 20 million years before the first apes even existed on Earth. Coming up, what this crater reveals about the secret world of impact hunting that most people never hear about. The surface truth, what mainstream science communicates to the public, is simple. Asteroid hits Earth, leaves crater, we find it, case closed. That's the version in textbooks and documentaries. The hidden reality. Here's what geologists actually deal with behind the scenes. Fewer than 200 confirmed impact craters have ever been found on the entire planet, and researchers believe that number is a massive undercount. Animator, split screen, showing dry, desert, crater, versus buried. Why? Because craters on land, in deserts, are easy to spot from above, but craters under oceans, under ice sheets, or buried beneath millions of years of sediment are nearly invisible unless someone happens to be scanning that exact spot for an unrelated reason, like an oil company hunting for drilling sites. This means the map of asteroid impacts you've seen is not a complete history. It's just the list of the ones humanity got lucky enough to stumble across. Real-world case study. The Silverpit story proves exactly how fragile that luck is. The crater sat there for 2 decades after its 2002 discovery, debated and unresolved, until a colleague at the North Sea Transition Authority gave researchers a tip to take another look, using better data. Only then, with new seismic scans and those microscopic shocked crystals, did the case finally close in 2025. More than 20 years after anyone first spotted the shape on a screen. Wait, it gets even more interesting. Silverpit isn't alone. In just the past few years, scientists have confirmed another massive hidden impact crater called Nadir, buried off the coast of West Africa, found the exact same way, almost by accident, during unrelated survey work. The mind-blow moment. If 2 major asteroid craters were sitting undetected in the ocean for millions of years, in areas humans have been actively drilling and surveying for over a century, then the ocean floor is very likely hiding far more impact history than anyone has ever mapped. So what does finding a 46-million-year-old crater actually change for you today? Let's talk about that. You've probably noticed that asteroid warnings show up in the news more than they used to. A close approach here, a planet killer, headline there. Here's the connection most people miss. The way scientists learn to predict future impacts is by studying the physical evidence of past ones. Every buried crater like Silverpit is a real, physical data point. It tells researchers exactly how much energy a 160-meter object releases, how far a resulting tsunami can travel, and what that kind of impact actually looks like in the geological record millions of years later. That data feeds directly into the current application, modern planetary defense. Agencies like NASA now run active surveys, like the Sentry system, specifically to track near-Earth asteroids in the same size range as the one that hit Silverpit. In 2022, NASA even tested a real deflection mission called DART, deliberately crashing a spacecraft into a small asteroid to prove humanity could actually nudge one off course if we ever needed to. None of that risk modeling would be as accurate without buried evidence like this crater, confirming what a real strike does to a real coastline. Here's the surprising parallel. This is the same reason forensic scientists study old crime scenes, or engineers study old bridge collapses. You don't design better safety systems from theory alone. You design them from proof. Silverpit is proof, frozen in rock, of what a coastal impact tsunami actually does. And this is just the beginning of how deep this goes, because there's one more layer to this story that almost nobody connects to it. Now here's something that most people never connect to this topic. the same time period when this asteroid hit, the Middle Eocene, around 43 to 46 million years ago, was also a major turning point for life on Earth. It's the era when early whales were transitioning from land-dwelling ancestors into fully ocean-based creatures, and when early ungulates, the ancestors of modern deer and cattle, were spreading across the planet. Animator. Split timeline showing. Ancient. Whale. Ancestor. Swimming. Nobody is claiming this one asteroid changed the course of evolution, but it's a genuinely wild coincidence to sit with. While a 160-meter rock from all space was punching a hole in the seafloor and sending a 100-meter wall of water across the ancient ocean, the ancestors of whales were quietly evolving in those same waters. Think of the ocean floor like an old attic nobody's cleaned out in decades. Every layer of sediment is another year's worth of dust settling on top of old boxes. Somewhere down in that attic, in a box nobody's opened, is a record of exactly what the world looked like the day the sky opened up over the North Sea, and that's the layer that sets up everything else we still don't know. So here's what we now know for certain. A 160-meter asteroid slammed into the North Sea 43 to 46 million years ago. It stayed completely hidden for over 40 million years until an oil survey stumbled onto its shape in 2002. And it took another 23 years of searching for microscopic proof before scientists could finally confirm it wasn't just shifting salt underground. The big takeaway: the ocean floor isn't empty space. It's the best-kept archive of Earth's most violent history, and we've barely started reading it. Now I want to know, did you already know there was a hidden impact crater sitting in the North Sea before this video? Drop it in the comments. I actually want to see how many of you had heard of Silverpit before today. In our next video, we're going somewhere even most engineers haven't, the hidden reason certain bridges are designed to sway on purpose, and why stopping that sway would actually make them more dangerous. Because the deepest engineering truths were never hidden to keep you out. They were just waiting for someone curious enough to dig.